Hello everyone, in this video we are going to find the value of x plus y plus z if it's given the following three equations. Let's start. So here we have to note that x, y and z are positive numbers. So here let me label each equation as follow. This is the first, this is the second, this is the third equation. So if I multiply the three equations, second equation times third equations, then I will get xy times xz times yz is equal to 24 times 48 times 72. And we see that x times x here x squared, and times y is y squared, and z squared is equal to, so let's try to get from the right hand side perfect square. So to get it we have to factor into prime factors. So we know that 24 is 3 times 2 to the power of 3, and times 48 is 3 times 2 to the power of 4, and 72 is 3 squared times 2 cubed. So now let's try to simplify. So we have a same basis, 3 and 3 squared, and we know that if we have a same basis we have to add exponents. So therefore 3 and 1 plus 1 plus 2, and here 2 and 2, so therefore 2 to the power of 3 plus 4 plus 3, so which is equal to 3 to the power of 4 times 2 to the power of 10. So now let me here write it. So we got x squared times y squared times z squared is equal to 3 to the power of 4 times 2 to the power of 4. And now how can we get from the left hand side perfect square? And we know that I can express 3 to the power of 4 as 3 squared to the power of 2, and 2 to the power of 10 as 2 to the power of 5 and to the power of 2. And using the following formula, so as we know, a to the power of m, let's say to the power of n, and times a to the power of l to the power of n. So since here the exponents are the same, we can write that a to the power of m times a to the power of l to the power of n. So using this formula, so we can easily now express the right hand side as a perfect square. This is going to be 3 squared times 2 to the power of 5 and to the power of 2. So therefore here I will get that from the left hand side x times y times z to the power of 2 is equal to 3 squared and times 2 to the power of 5 to the power of 2. And we can take from both sides square roots, so therefore I will get x, y, z is equal to, so since x, y and z are positive numbers, we have to simply get from the left hand side 3 squared times 2 to the power of 5. So now note that xy is equal to 24, so therefore we can substitute into xy 24 to get a first equation. The first equation is 24 times z is equal to 3 squared times 2 to the power of 5. So here we can easily find z. Z is equal to 3 squared times 2 to the power of 5 divided by, so we know that 24 is 3 times 2 to the power of 3. So now we can cancel here. We have here 2 squared, and this is going to be cancelled. This is 3. And 2 squared is 4. 4 times 3 is 12. So here z is equal to 12. So the second equation, so as we see that xz is equal to 48. So therefore we can substitute into xz 48. So then we can find y. So 48 times y is equal to 3 squared times 2 to the power of 5, and here we'll get that y is equal to 3 squared times 2 to the power of 5, and then we can factor 48 as, so 3 times 2 to the power of 4, and we can cancel here, we have 2, here 3, and therefore here y is equal to 6. And then last one, we see that yz is equal to 72, and therefore we can first substitute into yz 72 to find x. So therefore third one is 72x is equal to 3 squared times 2 to the power of 5 divided by sorry. Now x is equal to 3 to the power of 2 times 2 to the power of 5 divided by, and we see 72 we can factor as 3 to the power of 2 and 2 to the power of 3. And we see that we can cancel here 2 square and we can cancel, and therefore this is 4. So if you finalize that, we'll get the following solution: x is equal to 4, y is equal to 6, and z is equal to, so here, 12. Since we're looking for the value of x plus y plus z, so therefore we can add the last three equations to get x plus y plus z is equal to, so 10 plus 12 is 22. So this is our final answer. Thank you for watching. Please comment and subscribe to my YouTube channel.